Hi everyone! In this quick start tutorial, we're diving into VMware Secrets Manager, or VSecM for short. We'll get hands-on with this awesome cloud-native tool. We will deploy it on a Kubernetes cluster, then securely register a secret to a workload using the magic of SPIFFE, Spire, and MTLS behind the scenes. If you find value in what you learned today, please give us a star on GitHub at github.com/VMwareTanzu/Secrets Manager. Your support helps others discover this incredible technology. Don't forget to check out other videos on this link and explore the VMware Secrets Manager documentation to learn more about why it's the go-to solution for managing secrets in the cloud. Let's dive in. I am using an Ubuntu Linux machine, and I have already cloned the VMware Secrets Manager repository using git clone https://github.com VMware Tanzu Secrets Manager.git. I also have make installed on my system, and I have a local Docker engine up and running. Next, I'll run make cates delete to purge any previous Minikube test cluster I might have. As part of this quick start, we'll use Minikube. However, you can install VMware Secrets Manager to any Kubernetes cluster. So if you are following along with me, make sure you install Minikube to your system and make sure you have Docker up and running before you proceed. Next, I'll export Docker Content Trust 0 because to help install Minikube, I'll need it. 0 is the default value of Docker Content Trust, so if you haven't explicitly set Docker Content Trust to 1, you can just skip this step. Then, I'll run make Quickstart to initialize a brand new Minikube cluster. If this command gives a resource limitation warning, you can set up VSecM Minikube CPU count and VSecM Minikube memory environment variables to a suitable number for your system. And the VMware Secrets Manager installation is done. Since I'm using Minikube, I need to execute this eval statement to use Minikube's internal Docker registry. We won't strictly need this in this quick start, but running it won't hurt either, so I'll just go ahead and execute this command by pressing enter. Then I'll run make deploy to deploy Spire and VMware Secrets Manager to my cluster. This will take a while, and I'll fast forward in time with the magic of video editing. Now, let's check our paths first in the Spire system namespace by executing kubectl get -n Spire system. Then kubectl get -n VSecM system. All my paths appear to be healthy and up and running. During initialization, you might observe the Spire server and Spire agent restart a few times, and that's perfectly normal. They will eventually stabilize. While we are at here, it's worth to note that there is a make help command that will show you a list of options that you can execute as make targets on this project. Checking this output can also be helpful. To test our system, I'll deploy an example workload. In our particular case, this workload will use VSecM SDK to directly talk to VSecM Safe, to periodically fetch and refresh secrets that are assigned to it, as you can see on this diagram. We already have this app containerized for you, so all you have to do is run make example SDK deploy to deploy it to the cluster. If you are curious about the source code, you can always check out the examples folder in your project. Once deployed, I'll make sure that my example workload is healthy by running kubectl get -. Then I'll check its logs. Well, it's trying to fetch a secret, but not finding anything because we haven't assigned a secret to this workload yet. So let's do it, shall we? For this, I'll first find Sentinel, which is the main entry point to interact with VMware Secrets Manager, kubectl get -n VSecM system. And there it is. Then I'll execute this command on the pod. To break it down, Safe is the binary that Sentinel uses to exchange messages with VSecM Safe, which is our secret store, through a secure MTLS connection. -w example tells us that the name of workload is example. -n default means the workload is in the default namespace. -s VSecM rocks is the secret that we are going to securely dispatch to our example workload. When we run it, we get an OK as an acknowledgement that everything went fine. And once you check the logs of the example workload, now you'll see that the workload has securely received a secret. There are several advantages of this approach to using traditional Kubernetes secrets. First of all, Kubernetes secrets are restricted to a namespace, whereas you can dispatch VMware Secrets Manager secrets to any workload in any namespace. Secondly, when you change the secret, the workload dynamically updates it without needing to kill the pod. Third, you can have advanced template transformation over your secrets to convert them to exact shape or form that the workloads need, without modifying the application code. There are many other benefits. And if you want to learn more, we suggest you check out the official documentation at VSecM.com. Though, as far as a Quickstart tutorial goes, that's all there is to it. Until the next video, keep your secrets secret.